Hello everyone, this is Mr. Jackson, and today we are going to be moving forward again with our conversations on the nervous system, always starting back from this way of classifying all the different divisions. So far we've broken down the nervous system into the central nervous system, which is the brain and spinal cord. This is where we make our decisions. Okay, it's the integration of the inputs to decide on the outputs. But in order to receive those inputs and to deliver those outputs, we need this other main division, which is the peripheral nervous system. This is how the central nervous system communicates with the rest of the body. So that peripheral nervous system, we've broken that down into two big divisions. We have our sensory division, which is all about bringing information in from our internal and external environments, okay? And then we have, once a decision's been made in the CNS, the central nervous system, we will deliver whatever effect to whatever organ is going to have that effect with our motor division. We can further break down our motor division, and we already have. We've actually broken that down into somatic, which is going to be using skeletal muscle primarily, and that is going to be responses that we have voluntary control over, okay? So these are the things that we do consciously, the things we decide to do voluntarily. And now what we're going to do is we're going to move forward into this last part where we break down the remainder of these classifications, and we're going to be talking about the autonomic nervous system. You can think again about this as like automatic, because that's kind of what it is. It's the stuff that's involuntary. We don't have to think about it in order for these things to happen. And then we'll show what these two extra little branches are with the parasympathetic and the sympathetic. So let's get right into it. All right, so we talked about the somatic. Somatic was how we deliver effects, and this is under voluntary control. The autonomic nervous system is specifically going to be using nerve fibers that innervate our cardiac and smooth muscle, not skeletal, but our cardiac and smooth muscle. And if you think back to our concept on muscular system and the muscle cells themselves, please remember these are the ones that happen to also be under involuntary control. So this is going to naturally control involuntary movements. This also applies to your glands. These are the glands that are responsible for holding and releasing or secreting your hormones. And we're going to get to that as part of concept 3 in this unit. So more on that to come. Now, with the autonomic nervous system, it's different also in not just that this is involuntary, but also the actual anatomy of this system is different because it uses a 2-neuron chain as opposed to a single neuron in order to deliver the message. So a 2-neuron chain is used to connect the central nervous system to the effector organs. So what this is saying is this first neuron, the first neuron cell body right here, starts in the central nervous system, right? So it would be either in the brain or spinal cord, okay? Namely in this case, for the most part, most of them in the spinal cord, okay? But it starts in the central nervous system, and then it leaves that spinal cord through a gap in whatever 2 vertebrae it happens to exist in between, and it's going to exit that vertebral column, and it's going to synapse, right, or join with a second motor neuron. And that motor neuron is then going to extend all the way to whatever effector organ we have in question. So it's a 2-neuron transmission, a 2-neuron system. And the big thing to remember here is that we would start with this first cell body in the CNS, and then it leaves the CNS, synapses with the second neuron, and then that is what would ultimately deliver the message to whatever organ we need, okay? Now, we're going to go through this a little bit more in a slide here in just a moment, but it's important to also understand there are some differences in the 2 branches of this autonomic system, in the 2 ways we deliver involuntary control, okay? We do have 2 big neurotransmitters. Okay, again, these are going to be like those chemical messengers that help neurons deliver inputs or impulses. So neurotransmitter norepinephrine is going to be what we use in the sympathetic nervous system. We'll go over what that means in a moment. And ACH, or acetylcholine, is released in parasympathetic. All I need you to know right now is norepinephrine is typically going to be helping your body get revved up or excited. So norepinephrine is going to increase overall activity. And then ACH, or acetylcholine, is inhibitory, meaning that it's the one responsible for helping us calm down. So we'll break that down here in just a moment, but that's the little portion that we have down here, what it means. I like this image a lot, and this shows you an important distinction between the parasympathetic and the sympathetic nervous systems. Again, whenever it comes to parasympathetic, we'll break this down, it'll have its own slide, but parasympathetic is typically how you're going to rest and digest. It's calming, it decreases overall activity, and it's going to stem from the central nervous system in two places. High and low. It's going to either stem from the cranial nerves at the base of your brain, and those would be ways in which we would have that acetylcholine released and then transmitting signals to those effector organs. It'll either be the base of the brain or all the way down in your sacrum, right? All the way down using your sacral nerves. So that's parasympathetic. That's where those nerves originate, either at the base of the brain or in your sacrum. The sympathetic, right, that fight or flight, that increased activity, the let's get amped up, those are going to be everything else in the middle here, in your thoracic and lumbar vertebrae, or spinal cord. So they originate here in the thoracic and lumbar regions, and then they exit the spinal cord through those gaps in your vertebrae, and will deliver a variety of messages. Now, the nice thing for this level of anatomy and physiology is I'm not going to need you to really understand what each of these do, where they originate, or what, effector organs they innervate. I just need you to understand that there's this fundamental difference between rest and digest and fight or flight. Okay? So again, and we've already said most of this, parasympathetic, it uses what we call craniosacral nerves. That's because they originate at the base of your cranium or in your sacrum, okay? So, or your tailbone for the layman's term. And it says the ganglia, like that cluster of cell bodies, these are going to be sort of like a cluster of those second neurons in the chain. Cluster of those cell bodies as second neurons that take the information from that original neuron and then would branch out to a variety of effector sites. Those are far from the spinal cord whenever it comes to rest and digest. And they're going to be right next to the organs in which they innervate. Okay, so you can think of like that first neuron for rest and digest as being really long, and then that second neuron as being the one that's relatively short. And it calms you down. The sympathetic, we've already mentioned why, the thoracolumbar nerves. This is because they originate between the thoracic and lumbar spinal cord vertebrae, however you want to frame it. And these ganglia are actually still in the spinal cord. Okay, so this is a fundamental difference in our fight or flight in that those second neurons, those ganglia, those clusters of the cell bodies that are receiving info on the second neuron, those are actually still in the spinal cord. And so the second neuron is actually going to be the one responsible for traveling such great distances to their effector sites. And these are specifically responsible for amping you up. They are going to excite us. They're going to make us more alert. All right, so we're going to break down the autonomic nervous system, a little bit more info or specifics with parasympathetic and sympathetic, and that will conclude this organizer and all of the major divisions of the nervous system. We also have a couple activities, one that will go with your parasympathetic and one that will go with your sympathetic. So let's get down into that. Okay, so right now we are on this side, this side of our visual. Parasympathetic, again, it's your rest and digest, okay? Helps you maintain your body's energy, conserving your body's energy for later, okay? So this is where I don't really need anything right this moment. There's nothing too pressing that I need any of this for. So we're going to activate those mechanisms so that in the background, I am storing away what might be useful later. Okay, I do not need this right now. This is resting. This is digesting what I already have. Nothing new to speak of. So this is set up to communicate to only one effector organ at a time. We said our preganglionic cells, or those first neurons, are longer than our postganglionic cells. Remember, that just means that the majority of the cell bodies in those second neurons are actually at the effector sites, and then they'll go, less distance to actually deliver the message from the second neuron. These are going to specifically use the neurotransmitter norepinephrine and hormones, other hormones for both stimulation and inhibition. Now, we said that parasympathetic is inhibitory, but then why did you say stimulation? This is meaning that we can stimulate some organ to release hormones or to have some sort of an action that by itself would cause relaxation, as well as inhibiting the action of other organs, which would make them stop causing, activity or excitation. And then you also have hormones. These are just the chemicals that are released from glands into the bloodstream, whereas the neurotransmitters were released from neurons. Okay, so neurotransmitters from neurons, hormones, we'll cover those in concept 3 in this unit. Those are going to be released from the glands of your body. We'll have plenty of time to go through what all of those major glands are and how they help us. There's going to be a WebQuest activity. This is really cool. It's going to be right in line with those neurotransmitters, common drugs that we use in the medical field, and the phenomenon of addiction, which is a nervous system phenomenon. We're going to be looking through those 3 things in a very structured way in a really brief activity as a part of this unit. But for now, let's go ahead and finish up with this last little part of our division, which is the sympathetic nervous system. This is your fight or flight. This is over here on the right-hand side. And it's set up so that one stress signal can cause responses in multiple organs at once. Okay? Now, again, think about the need here. Okay? Rest and digest, we only do one organ at a time. It's because, we have the time. We can do that. It's not so immediately pressing that we rest and digest. It also might be why it takes us a little bit of time sometimes to wind ourselves down at the end of a very high stimulating day. But whenever it comes to your fight or flight, again, this is where we have to be highly alert, and we probably have to have a variety of organs helping us to become alert very, very quickly. This could be a survival mechanism that we've evolved for sure. And so one stress signal is enough to have several different organs all operating at once with one goal, and that's survival, right? Fight or flight. This is if I were walking down the road and believe that I saw a snake. That one stressor is going to activate a variety of different effects in my body that help me avoid the snake. Okay? So this is focusing on what your body has to do right now, like avoid a snake. It says the preganglionic, those first neurons, are shorter than the postganglionic. Okay, remember those second neurons for this fight or flight are still inside the spinal cord, and then they will shoot out to all of their different effector organs. We use the transmitter norepinephrine and hormones. I believe actually I should have said previously. Let me skip back here. Just want to make sure I'm not confusing anybody. I believe there was a typo here. Yeah. So I'm so sorry. On the parasympathetic, the norepinephrine is acetylcholine. Sorry, that was a typo there, and I just kind of was going along with it. Acetylcholine was the rest and digest. Hopefully you caught me on that. I had said that in a previous slide. And then norepinephrine, so sorry, that's the fight or flight. And And it's antagonistic, meaning it's opposing the sympathetic division, but they can work together. They can work together in that certain fight or flight mechanisms or high alert, high activity mechanisms might be necessary, while others need to not be doing as much of a job. This is really good for rerouting energy to go to a very specific place where we need it, as an example. And so naturally, this whole sympathetic division plays itself well to stress. And so with this side of the autonomic nervous system and the sympathetic, we will have a second short activity with a real world reading where we look at this phenomenon of stress and what is actually playing a part in how we respond to and manage distress, right? Which is that negative perception of stress. So that is more than enough, a little bit longer of a part here to finish out that graphic organizer. We do have a little bit more that we're going to look at when it comes to how your body handles reflexes and quickly responds almost again automatically to certain things that require quick responses beyond conscious control. And that will be enough to conclude all of the lecture material for this system. Very complex system. I appreciate all that you guys are doing to stay in there and to create meaning with me. So we will see you at the next part, and take care.